Welcome to lesson 2 of CSEC chemistry. Today we'll be continuing with matter, but specifically looking at how matter is classified or categorized. So today we'll be looking at states of matter that we did last week in terms of pure substances as well as mixtures. So matter that we know exists in two forms: either it's a pure substance or it's a mixture. Now, what makes matter pure substance? Pure substance means that it is comprised of only one type of material, right? So example of these would be like elements or compounds, which we're going to look at later. And mixtures would mean that it is comprised of two or more different substances, such as heterogeneous mixtures are the homogeneous mixtures, and these heterogeneous mixtures are broken down further into suspensions, colloids, and homogeneous mixtures. We're going to focus on solutions. So today let's talk about elements. Now, what are elements? Elements are substances that are made up of only one type of atoms, right? So under elements we can add atoms. Now, that raises the question, what exactly are atoms? Atoms are the small matter that makes up objects. So it's the reason why calcium is called calcium, because it has atoms in there that are unique to that specific property. So it gives this element a specific name. So these are the particles that make up the elements that we know from our periodic table. Right? So calcium are only made up of calcium atoms. Right? Then we go to compounds. Compounds are substances that are chemically bonded together, elements that are chemically bonded together. So therefore, if we combine two or more elements together, we get what we call a compound. Right? And these are chemically bonded, means that there has to be some chemical changes that happen to get these two or three elements to be clumped together, and they exist together unless you do other changes to make them separate from each other. So that's what makes a compound. Examples of compounds: we have water, we also have NaCl. This is the table salt that we use for cooking, right? So we notice here we have an element here and also an element here. So they are chemically bonded together, so therefore they make what we call a compound. Now, over the mixture side, we have mixtures, which are basically substances that are physically bonded together. So example, if we make sugar and water, or make some juice, some orange juice, these are substances: the orange, the water, the sugar. These are substances that we physically mix together. So we physically put them and combine them together to give us what we call a mixture. Now, mixtures are either heterogeneous or homogeneous. What makes a mixture heterogeneous is based on the particles that we can see. The particles that we can see, we can distinguish that this is the orange particles, this is those sugar particles, this is the water particles. Then we call them heterogeneous. So we see layers of the different particles within that mixture. And then for homogeneous mixtures, after we physically put them together, we just see one layer. So it's not able to distinguish that these are the particles that made up the mixture. So example of homogeneous mixtures are solutions. Solutions basically requires a solvent and a solute. What's a solvent? A solvent is what is doing the dissolving. So if we put salt in water, the solvent is the water. The water dissolves the salt particles, and that means that the solute is the salt particles. Those are what we dissolve in the solvent. So you'll probably hear from hence the universal solvent. Universal solvent we call water, because water is able to dissolve a lot of substances. Then we go to colloids. What are colloids? Now colloids are mixtures where the particles are not that small as in solutions, right? But they're not that big. So they're the in-between particles that they mix, but throughout the solution, you're going to see those particles suspended. So they're not settling at the top or at the bottom. The particles are settled throughout the mixture. That's what makes something a colloid. And then suspensions. As the name says, suspend. When you suspend something, it's coming down. So these big particles, bigger than colloids and solutions, actually settles at the bottom of your mixture. So therefore, after you mix it, put it down to settle, those big particles will fall to the bottom of your mixture so you can see them distinctively. And that's why we call them suspensions. Now, how to distinguish between them otherwise from their particle arrangement is we can shine light through, right? If we shine light through solutions, then it uniformly passes through it evenly because those particles are dissolved uniformly. For colloids, right, colloids will scatter light because they have big particles throughout it. When they hit those big particles, then they're going to scatter in different directions. That scattering of light through colloids is known as the Tyndall effect. Right? And then for suspensions, it is haphazard. So it's not uniform as the colloids, it's haphazard. So depending on where the light is striking this mixture, then it will give a different effect. Because most of the big particles are at the bottom, so it will have a different effect than if you shine it at the top part, where you have most of the smaller particles there. Right? So these are the two classifications of matter, right? And how they exist. Let's look further into more about matter. Alright, so the final part of today's lesson will be on the solubility curve. Now, first thing to know is what solubility is. The solubility of a solid is given as the number of grams of the solute required to saturate 100 grams of solvent at a particular temperature. So in essence, what this means is if we have 100 grams of a solvent, let's say water, it's how much grams of the solute that we need to put into that water to make it a saturated solution. Saturated means it cannot hold no more of the solute. If it put more solute in, then it starts to settle at the bottom. So it's no longer a solution, right? So in the curve, we normally have grams of solute on our y-axis and temperature change on our x-axis. So we can have two shapes of graphs. Now, the blue graph here represents that as the temperature increase, then the solubility of this substance will also increase. So what it means is temperature is increasing, it requires more solute as the temperature increases to start making this 100 grams of solvent solution a saturated one. So therefore, as it increases to a higher temperature, right, you have more spaces now, the particles start to spread out more, so you have more space that can hold more solute, and it still is a saturated solution. While this black graph here shows that as temperature increases, the solubility of this solution will decrease, meaning that you now require less solute in that 100 grams of solvent in order to create this solution, right? So that's what the solubility curve tells us, right? So it gives us a relationship between temperature and how much solute is needed in 100 grams of a solvent, right? And what this also shows us is that temperature affects the behavior of particles in mixtures. right? So example, if we look at boiling point, right? If we add more substance to a substance, example, if we put pure water to boil, we know it boils at 100 degrees and then it freezes at 0 degrees, right? But if we add, let's say, table salt, the boiling point now becomes higher. And the reason for that is the water now has excess, more particles to break down in order for it to start changing state, right? So therefore it increases its temperature that is required to do that, right? Now if you are freezing it, right, what you add the salt into it, then you're adding more particles. So now the particles are a little bit closer than if it was just pure water. So now you don't need a 0 degree temperature to get them connected closer to become a solid. They're already closer enough, so the temperature is now greater than 0, right? So the effect of adding substances to different substance will cause a change depending on the temperature, right? So that's it for today's lesson. See you next week where we'll explore more on our CSEC syllabus. Goodbye.